All right, welcome, ladies and gentlemen, to section 2 of chapter 5. We're going to be looking at verifying trigonometric identities. So we are going to be using a lot of the things on our new cheat sheet, our identity sheet that I gave you guys the other day. We're going to be looking at how to do it. The first couple slides, I'm just going to tell you what it looks like and how to do it, and then at the end here, I have a few examples that we're going to go through. All right, so what it looks like, it's essentially what we call a proof. I know most people don't really like that word because they think it's a very hard concept, but everything you do in the real world is basically a proof. You want to show that one thing equals another thing. And that's what we're doing here. We're going to say two things are equal to each other, but we have to say why. And the why is going to be using all of our identities to prove why. So we start with one side of the equal sign and we always end with the other side. We are not allowed to cross equal signs. We're not allowed to cross it, so we cannot subtract or add or multiply or divide on both sides of the equal sign while doing a verification process or a proof. And as I mentioned in class, all of the work is the little baby steps in the middle. So that's where you're going to be earning your points for all of the assessments and things like that. We're going to be working through the baby steps of equivalence, taking one thing from our identity sheet and substituting in for something else. So I have a few general strategies, some things to look for while you are working through the problems, and maybe they'll help you, maybe they won't. It becomes a personal choice as you get working through these problems. Now, work with only one side of the identity at a time. So you cannot add to both sides. You can't do things to both sides of the equal signs, as I was mentioning. You may work with both sides of the equal sign separately. So you'll see what I actually have an example like this coming up. It is much easier to start with the more complicated looking side and work to the less complicated. So like in our section 1, we dealt with simplifying expressions, and that's something that you can do here. You can take the more complicated expression and simplify it to the simpler expression along the way. If you can't think of something to do, and maybe you have a tangent in there somewhere, what you can do is convert the entire expression into ones involving sines and cosines. The reason we do that is because sine and cosine is the more familiar functions. And most of us are going to feel more comfortable dealing with sine and cosine than we are with secant, cosecant, cotangent, and tangent. So if you had a function or you had an expression that had tangent in it, you could change it to sine over cosine. And maybe the next move will come from that. And maybe you'll see where that should go. All right, so if you have fractions, little general strategy is to combine fractions. So you need common denominators. And usually through multiplication, other things show up in order to simplify the problems. If you have an a plus b, sometimes you might want to multiply by an a minus b, but you have to be careful using that correctly. Can't just multiply by something because you can't multiply to the other side. But usually where this is handy is maybe in like a fraction form where you multiply by top and bottom. And again, you'll see what that means as you get into the problems. The reason you do that is because you'll get something like, if you multiply these two things together, you'll get a squared minus b squared. And all of our Pythagorean identities can be written as 1 minus something squared or something squared minus 1, which actually could be factored to this if necessary. All right, so Pythagorean identity is one of our huge ones, like I mentioned before. Sixth, this is something you should always be thinking about. I should put this up higher on the list, but you want to make sure you pay attention to what you're trying to get to. If your answer only has a sign in it, I don't want to be working with the other side and start making a whole bunch of tangents and cotangents and things like that because I want only sine at the end. And again, this becomes something in your head as you practice these problems. This is the last thing, and I mentioned this in class. You must try something. If you didn't try anything, that means you didn't succeed and you didn't fail. Failing is something good sometimes. If you got something wrong, or if you did something wrong, that might actually lead you down the right path to find something that works correctly. All right? Don't just look at a problem and say, I don't know how to do it, I'm going to ask somebody else, if you never tried something. All right. And one of the things that I do in this particular set, because I've had practice with this, usually I'm thinking about 3 steps ahead. If I was to try this, if I was to try A, what's going to happen? Okay, well, I can see what's going to happen. Then I can see the next step. And if you can start seeing what will happen if you tried something, you will become better at these problems. None of the problems are too awful long. Some of them can be if you choose a very interesting step on your first step, one that doesn't really help you but makes the problem longer. Okay, this is a very practice-based skill. You're usually not going to be great at this the first try, so you just have to keep practicing. Most people that I've seen so far. All right, so here is our first example. We have, this is an identity, or it's verifying that this is a true statement. So we have this left side that equals to the right side. Now, we're not allowed to cross the equal sign at all, but we want to make one of these sides look like the other. And because the left side deals with fractions, that's the side that I'm going to use because it looks more complicated. It's actually easier to simplify an addition than it is to try to simplify a multiplication. So what I see here is one of our things on the last page said combine fractions whenever you can. Well, in this case, I have 2 fractions. They have different denominators. So in order to get common denominators, I have to multiply by each thing. So here I have to multiply by secant x plus 1 and secant x plus 1. Here I have to multiply by secant x minus 1 and secant x minus 1. So here on the left-hand fraction, my numerator here is secant x plus 1 over this thing foiled together. I get secant times secant, which is secant squared. I get a plus secant and a minus secant, which cancels. And then I have a plus 1 and a minus 1 makes a minus 1. Plus, my numerator here is secant of x minus 1. And I have the same denominator. And that's key for us here. If we were to combine these 2 fractions, notice I'm only working with one side. Remember, I'm not doing anything to the right-hand side in this particular case, so I'm not even going to worry about it right now. If I need to worry about it later, I'll worry about it later. So here I'm going to combine these 2 fractions. Secant plus secant is 2 secants, and I have plus 1 and a minus 1, that becomes 0. And my denominator is still secant squared x minus 1. Now, this doesn't really look like it's going to what I want it to go to in this particular case. But here I have secant squared minus 1, and I know that tangent squared x plus 1 is equal to secant squared x. So if I subtracted 1 from both sides, I would get secant squared minus 1 equals to tangent squared. All right. Now that still doesn't look like our answer. So we got to figure this out. Well, we have something over tangent. Well, something over tangent is going to be cotangent. It's just going to be squared in this case. So we can write this as 2 cotangent squared x times secant of x. Oops, not times. Equals. Well, again, we're getting closer. We have the 2 that we want, and we have a cotangent. But we don't have a cosecant, and I need to get rid of this square somehow. So I don't really know what else I can do, so I'm going to change everything to sines and cosines. It's one of your tips and tricks. Cotangent is cosine squared over sine squared, and secant is 1 over cosine. Well, now look at this. I can cancel my square, and I can cancel that cosine. So then I get 2 cosine x. I'm going to split this sine squared into 2 different sines. And if you agree with me here, cosine over sine squared is the same thing as cosine x over sine of x times 1 over sine of x. Well, look at that now. We have 2. Cosine over sine is cotangent, and 1 over sine is cosecant. And that's actually what we wanted. Right there, we have what we tried to get to at the beginning. That means we are done. That's a little check mark there. Now, yeah, that took probably 1, 2, 3, 4, 5, 6, 7 steps. That's kind of a long proof. 7 steps is kind of a long proof. Now, if it was myself doing this problem, I would have taken a couple steps out of here. But that's just because they weren't necessary steps. Like, I probably would have changed secant squared minus 1 right into tangent squared. I probably wouldn't have written this step here. And then there's like probably 1 step right in here that I probably wouldn't have done. But it's not bad. 7 steps is not a bad proof. All right, so there's our first example. Let's erase that. Let's go to our second example. We want to make the left-hand side look like the right-hand side. And what I'm going to mention another time, because I know there are people out there that want to do this, you cannot cross multiply. I'm going to write that very big. Do not cross multiply. Cross multiplication is a process, or is a thing that we do across equal signs, but we can't cross the equal sign. So we have to figure out what we're going to do to make the left side look like the right side. Now, you could start with the right-hand side and make it look like the left. But what I like to look at is, I like to look at this right here. The denominator in the left piece is a subtraction, which to me makes it a more complicated piece. So what we're going to do is we're going to do one of our other things on that last page where it said do the a plus b and a minus b to get a Pythagorean identity. So that's what we're going to do. 1 minus sine, I'm going to multiply top and bottom by 1 plus sine of x. All right, so if I multiply the top, and actually here's something I try to not do. I try to not multiply in. I try to not distribute because I know sometimes I don't really need to. If I need to at the end, I will. But right now I'm not going to. Here I get 1 minus sine squared x. And on our Pythagorean identity, we know that sine squared x plus cosine squared x is equal to 1. So if I subtracted sine squared from both sides, I would get this thing is now equal to cosine squared. So 1 minus sine squared is actually cosine squared x. Well, here, this is why I didn't multiply. Now, yes, I knew what was going to happen. However, I still, even if I didn't know what was going to happen, I wouldn't have multiplied here because I really hope things are going to cancel. If they don't, then so be it. So here I get one of my cosines I can cancel, and I can cancel one of those, and I get 1 plus sine x over cosine of x. And I'd be thinking, oh, what can I do next? But then I'd be like, oh, well, look, that's exactly what I wanted. That means we are done. That is what we wanted. We wanted to make the left side look like 1 plus sine over cosine, and we did. All right, we have one more example. This one looks a little bit more complicated and actually ends up being a little bit more complicated, but not awfully so. So we have to figure out what we're going to do here. And usually you're going to have to figure out the first step. And there's many first steps you could actually do to this particular problem. All right, let's think of something. Let's just go ahead and multiply. Let's do the same thing we did on the last problem. Let's multiply by the conjugate, because I know a 1 minus cosecant squared is going to be something, I think, right? We know that cotangent squared x plus 1 is equal to cosecant squared x. Cosecant squared x. So here on my denominator, I get 1 minus cosecant squared x, and I get that over or underneath cotangent squared x. Okay, so then we go along like this, and we hope that this is going to work. And guess what happens if it doesn't work? Well, we just try again. If it doesn't work, you try something else. Now, normally, as long as you do something legal, it will eventually work. And maybe you just didn't choose the right or a decent first step. Any first step is legal, or is okay as long as it's legal. So 1 minus cosecant squared. So how am I going to get 1 minus? So I'm going to have to subtract cosecant squared and subtract cotangent. So this means 1 minus cosecant squared x is equal to negative cotangent squared x. Well, that doesn't look right, because that means I'm going to get a negative 1 here. Let's see. So here I get cotangent squared over negative cotangent squared. And that's equal to negative 1. But that doesn't seem right. So what are we going to do? So here we go. Let's see if we can make the right-hand side equal to 1. Let's hope. Because 1 doesn't look like this yet. And there's not really anything that I can do to a negative 1 to make it look like all this. So let's start with this thing here. Let's go, okay, let's try to distribute here and here. So this becomes cotangent x secant of x minus cotangent of x times tangent of x. Well, cotangent of x times tangent of x, we know that those are reciprocals, so therefore that is 1. I don't know what to do with cotangent and secant. Well, okay, so cotangent and secant. Here we go. Cotangent is cosine over sine, and secant is 1 over cosine. So that means my cosines cancel. And I get 1 over sine minus 1. That doesn't really look like anything yet. So let's try something else here. So I get 1 over sine of x minus, I'm going to make common denominators here. Oh, I hope somebody else caught my error, because Mr. Nelson was not paying attention to what he was doing. Because when I multiply by the 1 minus cosecant, see, this is all stuff that you're going to do too. I have to have the 1 minus cosecant x up here. All right, so this is going to get very interesting here. So let's go ahead and do a little bit of an eraser, because I have an eraser now. I used to not have an eraser. All right, there we go. Now Mr. Nelson's on track. So here, this still becomes cotangent squared x times 1 minus cosecant x all over negative cotangent squared. So the negatives, or the cotangents, cancel. I get negative 1 minus cosecant x. If I distribute that negative, that becomes cosecant x minus 1. Then, if I look at this, 1 over sine is cosecant x minus 1, and looky there, I get the same thing. So here is a good example of what happens when you make errors, right? So I made a very big error. I forgot to look at the numerator as I was going along. So I got a negative 1, which, if you notice my hesitations in my voice, I knew I couldn't get a 1 out of the right-hand side. So as I was talking, I was trying to figure out where I had made my error. But notice this, even if I did this right on the left-hand side, I would have gotten this, cosecant x minus 1. But the right-hand side didn't look like that, so I still would have had to work with the right-hand side. And what I did is I simplified the right-hand side down to something. Well, it just so happened they simplified to the same exact thing. And so therefore, this is a true statement, and you are complete. All right, so that finishes off this video. I will upload another video shortly, or after a while, of more examples of these, just straight from your textbook, not your homework problems, obviously, but more examples. And I hope you learned something. I hope you start your assignment and try these problems. They're very good problems to do. All right, I will see you guys later.